Hello students, welcome back. In this video we are going to go through Chapter 3, Section 1, Measures of Center. Now a lot of this is going to be repeating for you, so if you feel very strongly about some of these things, I won't say to skip through them, but I don't think I'm introducing as much new material, but I will say that I will be showing you how to solve a lot of these things using technologies that you might not want to know, so that might be where you are going to be learning or being exposed to the material. So maybe if that means watching the video at a sped up version up until there's new material and then watching it at normal speed, that's up to you. I just want to kind of preface it with that. So the key concept here is once we have a whole data set, we want to determine measures of center. What do we mean by measures of center? And you've done measures of center. You just might not have called it measures of center. Basically, we are doing mean, median, and mode. Okay, so mean is of a data set is the measure of center found by adding all the data values and dividing by the total number of data values. So if you have the speeds right here are 38.5, 55.6, 22.4, 14.1, and 23.1, you may want to know what the mean is. So you're going to add all 5 of those data values up and then divide by 5, and then boom, you have your mean being 30.74. Okay, one thing that we want to caution is never, they even capitalized it for you. Never use the term average when referring to a measure of center. The word average is often used for mean, and I'll be honest, I do it as well. Sometimes it'll slip. But it can sometimes, the word average can often be used for other measures of center, not just mean. So we try not to use the word average. We try and always stick with mean. So here is your notation. This little sideways M, Greek letter sigma, denotes the sum of a set of data values. So add all the values up. X is the variable usually used to represent the individual data values. Lowercase n represents the number of data values in a sample, and capital N represents the number of data values in a population. In addition, we have X with a little line on top of it. We call that X bar, and it is the mean of a set of sample values. I'll say that again. X bar is mean of a sample. Then we have mu, which is kind of a U with a long leg on the left-hand side. Mu is the mean of a population. So notice the difference. Again, mean is calculated by summation of all the values divided by the number of samples for X bar. And then mu is the mean of calculating all the X values divided by the total number of people or things in the population. Okay? This might be new for a lot of you, so I would pause, or not pause, but view the video at normal speed for this part. Sometimes we might need to calculate the mean from a frequency distribution. So if we have a frequency distribution, we want to determine a mean from that. So a problem with a frequency distribution is we don't know what each of the individual data points are. Think back to section 2.1 where you had your classes and then you were just told the frequency of each class, but not the individual data values. So all the data values could be the lower limit of that class or the upper limit or somewhere in between. So to play it safe, we are going to be using the class midpoints. So to find the mean of a frequency distribution, first multiply each frequency and class midpoint and then add up the products. So the frequency multiplied by the class midpoints, multiply them together, and then add the products. Okay, so this is the McDonald's problem that we used before. And say we want to determine the mean of this. Okay, so the class midpoints are here. That's just halfway between these two data points, or find the mean of these two. So then we're going to multiply our frequency multiplied by the class midpoint, and we get these values in this column over here. And then we're going to do a summation of that. So add them all together, divide by your total number of frequencies, and what did I do? I don't know, somehow I went to the beginning. Add them all together, divide by 50, and voila, we have our X bar. And this is an approximation because we use the class midpoint instead of the original list. So if we were more accurate, we would have had the list of 50 individual times and then did the mean of that. But since, we have just the table right here, well, I don't know, 11 of these could have been 124. 24 of these could have been 125, not 149.5. It could have been some above, some below. That's why we just do the midpoint. Just take basically a mean of a mean, if you would. Okay, weighted mean. This is also could possibly be new for you. So weighted mean is when different X data values are assigned different weights, we can compute a weighted mean. So this is actually a really good example because if you're a college student, you're going to definitely want to know how to calculate your GPA. So I think this is one of the more important examples because I can guarantee you that you will want to do this at some point in your college career. So in her first semester of college, a student took 5 courses. Her final grades are as follows, along with the number of credits for each course. So she got an A in a 3-credit class, an A in a 4-credit class, a B in a 3-credit class, a C in a 3-credit class, and she failed her 1-credit class. Bad, boo. Okay, so then your GPAs are as follows. An A gives you a 4.0, B a 3.0, C 2.0, D 1.0, and an F you get no credit for it. And she wants to know, hey, what's my GPA after this one semester? Okay, so we will need to do a weighted mean at that point. So replace the letter grades with the corresponding data quantity points. So we said that an A was a 4, so she got 2 4s, 1 3, 1 2, and an F, so 0. And so all we have to do is we multiply the number of credits, multiply by the GPA for that individual class, and then do a summation. So again, she got an A in a 3-credit course, so 3 times 4, plus an A in a 4-credit course, add those up, a B in a 3-credit course, a C in a 3-credit course, and an F in a 1-credit course. And then divide by the total number of credits she took, and here is her GPA for that semester. Hey, she's above a 3.0. Good girl. Okay, so that is her first semester GPA. Median, I'm sure you all know median, but we will go through it as if it's the first time because it is not a prerequisite for this course. So the median of a data set is the measure of center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. So median, middle. So there's 2 ways we might have to calculate median depending on if the number of data sets is even or odd. If the number of data values is odd, then the median is exactly in the middle. If the number of data values is even, the median is found by computing the mean of the 2 middle numbers. So let's look at an example. Find the median of the first 5 data speeds for Verizon, 38.5, 55.6, 22.4, 14.1, and 23.1. And they're all in megabits per second. Okay, so first we have to sort the data values by putting them in ascending order. And because there are 5 data values, and that's an odd number, of course, so the median is going to be right smack dab in the middle, or 23.1. Now, let's repeat the previous example, but we're going to introduce a 6th data speed, 24.5. So that is, find the median of these 6 data speeds right here. Again, put them all in ascending order, but now there's 6, so there's no actual number smack dab in the middle. So what do we have to do? We have to take the mean of the 2 middle numbers, which in this case would be 23.1 and 24.5. Add those together, divide by 2. Our median for this is 23.8. Okay, resistant. A statistic is resistant if the presence of an extreme outlier does not cause it to change very much. So we would say that the mean is not resistant. If you add an extremely high value to this at the end over here, hey, it's gonna really change the mean. So let's say we got rid of this 55.6 and replaced it with 355.6. Well, that's going to greatly, drastically change the mean for these values over here. However, if we were trying to see the median by adding a 3 in front of here, well, it's actually not going to change. The median would still be the same. So we would say that the median is resistant. The mean is not resistant. The mode, again, if you need a refresher, is the value that occurs with the greatest frequency. So a data set can have one mode, more than one mode, or no mode. So when two data values occur with the same greatest frequency, each one is a mode, and the data set is said to be bimodal. Bi meaning two, there's two modes. When more than two values occur with the same frequency, then we would say that's multimodal, multi meaning more than two. And then when no data value is repeated, like every single one only appears one time, we say that there is no mode. So find the speed of these, find the mode of these sprint data speeds. The mode is 0.3 because that occurs the most often. In this case right here, 0.3, 0.3, 0.6, 4, and 4, that would have two modes because 0.3 and 4 both occur twice, which is the most. If 4 occurred 3 times and 0.3 occurred only twice, then only 4 would be the mode. And then no mode would be none of the values are repeated, as shown in this example. Next is mid-range. The mid-range of a data set is the measure of center, that is the value midway between the maximum and the minimum. So it's found pretty simply by taking the minimum value, adding it to the maximum value, and dividing it by 2. So here's your formula for the mid-range. You're taking your smallest value, your largest value, and then you want to get what the halfway point is. So you just take the mean of those two numbers. So here's a quick example. You have 38.5, same 5 values as before. So what's your minimum? 14.1. What's your maximum? 55.6. So your mid-range is the halfway point between them. So add those two together, divide by 2, boom, that's your mid-range. Here are some steps for how to do that using your calculator, and a video of that as well. And I'll also just show you, I actually probably might prefer Excel for this. Let me just randomly type in numbers. Okay. So in this cell over here, in a blank cell, I'm going to do enter, and then I'm going to do average. I know, they broke the rule of statistics. Whoa. So average, and then average of what? Average of all these numbers. So highlight, click and drag, close parentheses, enter. And that's my average of those numbers. I can also do the median of those numbers by doing equals median of all these. I think I can actually even do mode. Let's see. Okay. So looking at it, I would say that 5 is the mode, maybe 6, just to kind of check it. Okay, so then they're saying that the mode is 5. 1, 2, 3, 4, 5. 1, 2, 3. Yeah. So the mode is 5. So that's just showing you how to do that using Excel. You can also use StatCrunch as well. So let's just randomly create numbers. Let's do 5 a few times so we know that's the mode. So we're going to go to Stat, Summary Statistics, Columns, because we have everything in a column. Variable 1, we want all these values. Okay, so we have our mean. We'll get to these actually next section. Our our median, our range, and other data values as well. So that's just showing you how to do it with StatCrunch, Excel, and then I gave you directions on how to do it using your calculator. And that concludes this section, guys. Thank you.